Hi, so there are multiple ways to show addition for two-digit numbers. So I'm going to start with the bigger number because of the commutative property. I can switch these places, so it doesn't matter if I start with 24 or 32. Please don't forget that in subtraction, it does matter. You cannot switch them. The commutative property allows you to switch them in addition. So I can start with the bigger number, and I'm going to, just like in Number Talks, I'm going to break apart this. Very good. And I have my special guest here again, Kaylin. What is this number? Do you remember what I told you it is? This one right here?
It is 24.
Very good. So I'm going to add 24, but to do that, I want to show my jumps on a number line to show my thinking. And one of the ways that we do this when we're not adding with the standard algorithm, which is adding the ones place and then the tens place, which we still do that, but we can show our thinking on a number line. So we would break this into expanded form, which would be 20 plus 4. And then we can further break down that 20 into doubles or part whole, which would be 10 plus 10 plus 4. So I'm going to show that real quick and label all of my jumps. So 32, and I'm going to add 10 plus 10 plus 4. So 32 plus 10 would get me to 42. Yes, ma'am. What do you need? Yes, that's number 32. So there's 42, and plus 10 more would get me to 52. I'm going to mark that. And then, so I've got my 20, and then if I want to add the 4, I can do 52 plus 4, and that's 2 ones and 4 ones, which gets me to 56. And I want to mark my 5s. Notice over here I marked my 1s. There's my 5, which is halfway between 50 and 60. And so 56 would get me just past the 5. So now I have plus 4. And then I can show on a number line how I start at 32 and add 24. And my answer is, as we showed there, 56. And I will be right back with some more strategies for adding two-digit numbers. Hi, so a second way that we can that we can add two-digit numbers is by using base 10 blocks. So we've talked a lot about adding in our minds in math class. So we can do 65 plus 31, which is the same as 10 plus 10 plus 10 plus 1. So 65, 75, 85, 95 plus 1 is 96. So we talked about that. We also have talked about adding the ones place first using the standard algorithm, which 5 plus 1 is 6, 6 plus 3 is 9. But let's also show that here with the base 10 blocks. So if I'm showing the first number, 6, that's 10, 20, 30, 40, 50, 60, and then now I'm going to show the ones. 1, 2, 3, 4, grab 5. Okay, and now I want to show 31. So 1, 2, 3, and 1, 1 to represent the ones place. Okay, and if I count all of that up, 10, 20, 30, 40, 50, 60, 70, 80, 90, 91, 92, 93, 94, 95, 96. And then I can see the addition problem that I just did. All right, so the standard algorithm we actually, in class and in the curriculum, we will not be learning for a few more weeks, but our students are amazing and they're already using it. And so I want to touch base with that right now. You can take the numbers, and if they are side by side in a math problem, 12 plus 24. A lot of times we are already adding the ones first and then the tens. And remember that that's important to add the ones and then the tens, because eventually we're going to be having to regroup our numbers. So 4 plus 2 is 6 ones. 4 ones plus 2 ones is 6 ones. And then this is my tens place, so I have 2 tens plus 1 10, or 1 10 plus 2 tens. I can go in either order because of the commutative property. So 2 tens plus 1 10 is 3 tens, and when I read that, it would be 36. So my math sentence would be 12 plus 24 equals 36.